if I want to solve this, it's kind of like this problem, because it's not a proportion, it's not a fraction equal to a fraction, it's one of these. So we have to find the LCD and multiply everything by it. But before you find the LCD, you first have to factor both denominators. So for this denominator, when you pull a 2 out, you're left with x minus 1. For this denominator, when you factor it, it looks like that becomes, it's a difference of squares. So it looks like it's going to be x minus 1, x plus 1. I'm going to cross those out. Those are my new denominators. Now, looking at those, I want to find my lowest common denominator, my LCD. So I'll take this whole first denominator, the 2x minus 1. And then I look at this one. All right, I have x minus 1. I already have that, but I need an x plus 1. So I needed an x plus 1. So let's look at this. Does this LCD have this? Yep, right there. Does this LCD have both those? Yes. So that's my LCD. Now what's kind of crazy is we're going to take this whole thing, this big old thing, 2x minus 1, x plus 1. You're going to take that whole massive thing and multiply it by every piece. And it's going to look kind of ugly. Okay, it's going to be really long and kind of ugly. So you're going to have 2 times x minus 1, x plus 1. Okay, and that's going to be times this, which is x over 2 times x minus 1. And then you have a minus, and then we have the 2 times x minus 1, x plus 1. Have that again. And that would be 4 on top, and that would be x minus 1, x plus 1 is the bottom. Alright, and then next we have equals, and we have that 3 there, but like again we have the same top, so it's 2 times x minus 1, x plus 1, but we have this 3, this last little bitty 3. Okay, it's kind of tight there. So we multiply this LCD by each piece. The brown is my original. The blue, or whatever color, that aqua, is my LCD by each piece. Now what does that LCD do? Is what you'll notice is it cancels. So what you're going to notice here is you're going to notice this is going to cancel with this, and this cancels with this, leaving you these two, which is x times x is x squared, x times 1 is x. So that's the first piece. All the denominators dropped out. The next, these cancel, and so do these, leaving you 2 times 4, which is 8. And for this, the 2 and the 3 gives you 6. And then if we FOIL this out, we FOIL that out, you get x squared minus 1. So if you FOIL this out, you get x squared and minus 1, and 2 times 3 is 6. Now you want to solve this. It has x squared, so it's going to be a quadratic, so we're going to get the x squareds by themselves. First step would be to distribute this 6. Over here, some combine like terms, so it looks like we have x squared plus x, and that's minus 8. And to solve this, let's see, we want to get the x squareds to one side, and I want to make them positive, so I'm going to move everything this way. So I'm going to minus the x squared over, minus the x over, I'm going to add the 8 over. So this is all gone, leaving me 0 equals, looks like 5x squared. That'd be negative x, and this looks like 2. And then we solve this. I can't factor it, so I got to use quadratic formula. Quadratic formula is x equals the opposite of b, which is negative 1, plus or minus the square root of b squared, negative 1 squared, minus 4 times a, which is 5, times c, which is 2, over 2 times a, which is 5. So negative b plus or minus the square root of b squared minus 4ac all over 2a. And that looks like we're going to end up with x equals the opposite of negative 1 is positive 1. Plus or minus looks like the square root of 1. And negative 4 times 5 is negative 20. Times this looks like it's going to be negative 40. And 2 times 5 looks like it's going to be 10. From there, it looks like we're going to have 1 plus or minus. It looks like negative 39. A negative is imaginary, so I comes out 39. Because this negative 39, and you can't have negatives inside of a square root, so you have to make that imaginary. And that 10 stays on the bottom. That looks like the answer right there. Because 39 doesn't simplify anymore. I is because it's negative. That is your answer using the quadratic formula. It's a really long problem.